Hello everyone, and welcome back to my R tutorial series. Today I'm going to show you how to get your data in and out of Excel and R, and how to save and manipulate your data as if it were a data frame, which is what it's going to become when we bring it from Excel to R. We'll also talk a little bit about packages here at the beginning, because understanding how to use packages is important to understanding how to bring it in from Excel, since we're going to use a package to do that. So a package in R is like an extension of the base R code that somebody else has created and published for you to download and install. The first thing to do is to install it, which you can go up here to the Tools tab to do. There's at the very top of this menu, there's an Install Packages button. Now, this will pull it from the CRAN repository, which stands for Comprehensive R Archive Network, and it holds documentation for all of the individual packages. So if you know what packages you want to install, you simply type their names in here, and then you can either separate them with a space or with a comma. If you start typing in this box, R will also try to give you a list of autofill options in case you don't know exactly what it's called. So for this episode, you're going to need a package called XLSX. Now there's a couple different ones here, you just need XLSX. You will also, if you're brand new to R, go ahead and just install this one, because this will come in handy both for me showing you stuff this episode and also in the future. If we separate by a comma, and then you want to type PLYR. The Plier package is a big statistical and data manipulation package, and I find it pretty useful to use some of the commands that are within it. So this should have a default library to install it into, so you shouldn't need to worry about any of this other stuff. And you definitely want to make sure it's installing the dependencies, because that means that if any of the packages that you've specified need another package in order to work, it should also install those. So if you just click install, mine I've already got, so I don't really want to do this because it will cause me to restart and do other things, but you can run all of that and it should install the packages for you. Now there's another way to do that. If you wanted to do the manual way, you can just type in install.packages, and then if you have multiple, it's basically just running this command, which is what that menu just did. You can concatenate them and put the names in quotes, XLSX, Plier, close the parentheses. You can do just one. You don't need to concatenate it if that's the case, if you're just installing like Plier. But I always find it easier to go up into the Tools menu and do it that way. So, just a little bit about the CRAN repository. Again, that contains all kinds of documentation, usually from the authors of the packages, and it will often try to explain some of the commands, arguments, functions, and any other information regarding a data set or a package, albeit not the most helpful sometimes, just because sometimes it's explained for other programmers and not really for laymen or beginners. So if we wanted to look at either a package or let's just say an individual command within a package and get the CRAN information from it, you can either go to the website, which is, if I can find it, it's cran.r-project.org. So I'm going to type it in here, cran.r-project.org. So up there you can find installation files for R, for the different packages, and all the documentation that you might need. Or you can view it here in the help pane, simply by typing one or two question marks before the name of the command or package. So let's say I want to ask this about the command plot. Now plot is in base R, but there are some other packages that will contain a plot function, so that is also important to know. Sometimes there are different versions of the same command that you need to choose between. So if I hit that with two question marks, that's going to search the entire database. And so you'll notice that it pulls up ggplot2, which is a really popular plotting package, which we'll talk about later because it's a lot more complicated than just base R. and there's all kinds of other packages that are in here. But if I simply want the plot command from base R, I can just use one question mark, which I think only searches base R, or it at least limits the search by the command name, I think. So you'll notice there's a couple different parts to this one just because it's such a big and versatile command. But generally you probably just want the default scatter plot, and you can click on that link and then go to this, and it will give you a list of all of the arguments that it takes, and then usually an explanation to some extent of the different arguments. Now, whether or not these are useful depends on how the author decided to write it and how simple they wanted to make it. So sometimes this is helpful, sometimes it's not. But that's a useful little trick to finding help on something specific if you're not sure exactly what to do with a command. So there are a number of different packages that can write or read Excel files. Of course, the one I had you install is the one we're going to use today. So in a code chunk, or if you're working in a script, just in the script, you're going to need to tell RStudio that you want to use this command, or this package, I mean. So you want to tell RStudio in some way that you're going to need to use commands from this package. To do that, you can do one of two ways. You can use either library, which is pretty common, and then you just put the name of the package in it, so XLSX, or you can do require XLSX. It's the same format, just library or require. The difference between these is subtle. Library creates an error if the package isn't found. So if you tell it to library a package that maybe you just forgot to install, and then you have a bunch of other code below it, and you run the whole chunk, it will stop it at the library command because it didn't find the package. If you use require, it will simply give you a warning instead of an error, which does not cause the following command or the following code to stop. So if you use require, it may not find that package, but maybe you don't actually need that package and you're just requiring a whole bunch of them all at once. Then the other code can proceed without worrying about whether or not that package is installed. Usually require is useful specifically for creating functions. Otherwise, there isn't a whole lot of difference to this because you'll probably realize pretty soon that you don't have that package installed yet. So you can just pick one of these to use. I've been using library lately, so I will continue to do that. Now, so now we've called the XLSX package simply by running this line of code. And now we need to know where our data is found on your computer or server system. So some of this is going to have to require a little bit of knowledge of how your file system works on your specific operating system. So I'm using Windows 11, and in Windows you can use the File Explorer. So this can pull up all of your different files, and it has a number of built-in folders. For me, my home directory is in my Documents folder, and this is just all the stuff that happens to be in there. And then I usually put all my R stuff into RDocs, a folder that I created. You'll see a whole bunch of stuff here, including this other subfolder called R Lessons, which is where I'm keeping all of my files for these lessons. And I have an Excel thing in here that I've created. Now this is fake, randomly created data. I just threw a bunch of numbers and tree names and things like that into an Excel folder and am pretending that this is actual data. So keep that in mind. This is not actual data. I'm not using anybody's data for this. So let's say this is the one that I want to use. Now, it's helpful to know how to do that in the R Explorer as well, the R File Explorer. So again, my home folder is my Documents folder. And then I keep things in RDocs, and this particular file is in R Lessons. So if I want to get this XLSX file out of here, I simply need a command from the XLSX package called read.xlsx. Now, this also has functionality for other file types. So if you have a CSV, which is a comma-separated values format, this is a lot like an Excel spreadsheet, but in Notepad kind of format. So instead of cells, it's separated by commas for each row, or each column is separated by a comma and in rows. You can also have TSV, which is essentially a simplified Excel format, or XLSX might be just a modified TSV. TSV is tab separated values. It's essentially the same thing, works mostly the same way. For our purposes, it doesn't matter too much. But if you have a specific file extension that you need to read, it should work pretty much the same way as doing an XLSX. So to do this, we now just need to we need to save this as an object first. I almost forgot. So I'll just call this data. This will become a data frame. So just like the ones that we've used previously. And we're going to read the XLSX file. Now, before I get further into this, let's take a quick look at the actual data. We need to make sure that it's ready to be put into R. So this is what I've come up with. I made this kind of at random. I'm pretending that we've taken measurements and observations from 5 different tree species, 10 of each species. So there's 50 rows of data plus 1 row of the column names. You'll notice that there's no spaces or commas or quotation marks in this document. That is the most important thing. No spaces. Spaces are a little bit more forgivable from R because it will usually just coerce whatever that cell is into character format, so it'll put it in quotes. You may not always want that, so it is important to make sure that you know where your spaces are, but spaces are not the end of the world. However, commas and quotation marks can and will break a document it'll break the data frame, I should say. We'll make it so that R cannot read it properly. It might change numeric data into character data, which would completely negate the ability to do math or statistics with it. And it could change all kinds of things that you really don't want it to change. So it's important that you keep those characters out and use underscores or periods as I've done. So in the names, I have these are going to be character format, but I have underscores. In the column names, I have underscores, and then everything else is either a decimal number or a logical or Boolean, and nothing else. So you also want to make sure that you don't have a whole bunch of, you don't explain, oh yeah, height is in meters. You don't want to put this stuff over here because R will try to read all this and it'll have a bunch of extra blank stuff. You can do that as long as you specify which cells you want to actually use. And I think this particular package really prefers that you do that. Sometimes it yells at me if I don't, even if I have nothing else in my document. So let's now look at how to read this document into R. So the first thing you're going to need to do is add the file argument. Now, again, you don't need spaces between the name of the argument, the equal sign, and the answer to the argument, but I like to put spaces. I also like to put each argument on its own row. You don't need to do that either. I just find that it looks nicer and it's a little bit easier to read. So for the file argument, you just need to put in the file path. Again, this needs to include forward slashes, not backslashes, and it needs to start from wherever your home directory is, or wherever it is on your computer system. So it may not be your home. If you have it on, say, a flash drive and you just want to bring it straight from there, it might be like your D drive or your F drive or something like that. You'll have to make sure that you know what the file path is. So for me, it's in my home, and then in the home, it's in RDocs, and then in RDocs, it's in RLessons, and then the name of the file, r_lesson4_data, and you need the extension, of course, so .xlsx, end quote. After that, you can put a comma, and again, you don't need a new line here, but I like to put new lines. The next argument you want to have is actually a set of 3 different arguments. It does not matter what order these are in if you're specifying the name of the argument. So you can put these in whatever order you like. Then you need the sheet index. Note the capital I there. And that is just going to be whatever sheet it is in Excel. So for me, I only have 1 sheet, but if you have multiple, just put the number of the sheet that you're on that you want to import. You may also, I think you can use the name of the sheet in quotes, but it's probably just easier to use a number. Another comma for the next argument is row index. Again, the I is capital. And for this, you can either do a series with a colon, like I've shown in the past. So for me, there's 51 rows, including the header. So it'd be 1:51, that's 1 through 51. Or if you have specific rows that you want, but not all of the rows, or maybe they're just not contiguous in the document, you can use the concatenate argument here and say, let's say you wanted 1, 5, and 10, and you can do it that way as well. For me, I do want all of them, so I'm just going to do that. And then COL, short for column, index, call index. Again, the I is capital. And I have 6 columns that I want all of. Now, the final, or at least the last important one that you want to have is header. I think by default this is true, but you want to make sure this is true if you do have these column names in your Excel document, and if you're including those in the row index. So row 1 is my column names. I need to tell R that so that it doesn't think those are more data points. So I tell it header is true, and it will assume the first row of each of these columns is the name of that column. So again, you can either use just a T here or true as long as it's all capitalized. And then you can just close off that parenthesis and run that code. Now, you'll notice that I've created a data frame right up here, and I can click on it. It will tell me there's 50 observations, so 50 rows of data, and 6 variables, so 6 different columns. You can click on the data, and you can get the same thing that's in Excel in R. Now, let's see. There's a couple of useful commands that I want to show you that can be used to reorder a vector or a data frame. They kind of work in a similar way, but one is for vectors and one is for data frames. So let's say you want to just look at one specific column out of this data frame as if it's a vector. We can even save it as a vector. So let's say you just wanted to look at all of the heights of all of these trees together, just pretending they're all one species, or maybe you have data for all one species that you want to sort. Let's say you want to sort it either alphabetically or numerically. You can do that with a base R command called sort. It's quite simple, really. You just use the sort command, and then you tell it what you want to sort, that being, let's say, data, but we just want column, what column is that? Column 3. So if you remember matrix notation, you'd have in the square brackets, you'd have the row number, which is just all rows, so we'll just leave a space there, comma, the column number, 3, and then close that. So you also don't need the space there. So you want to sort the third column of data. And that will just read it down here. You could save it as an object, so you could call it heights, and do that. And then you get a vector here, and then we could just look at it down here, heights, and notice that it's sorted from smallest to biggest. So if you wanted to do it in backwards order from largest to smallest, you would then just need to add an argument after your vector called decreasing. And by default this is false, but if you set it to true, it should make it from largest to smallest. If we just look at it, yep, now it starts with the biggest one and goes to the smallest one. So that works for vectors. Now, how do we do that for a data frame with multiple columns of different types of data? Well, if we look back here, there's, each row has an associated data point. It's this tree number. So these are just numbered 1 through 50 and doesn't really mean anything since it's fake data anyway. But let's say we wanted to sort these trees and know, the height, the DBH, the leaf length, and whether or not there was a bird's nest in it, based on, from the tallest tree to the shortest tree. Let's say we wanted that information. How would we do that? That's where this package called plier comes in. And actually, I'll go ahead and make a new code chunk for this, just to keep it separate. If we want to call the plier package, again, you have to make sure it's installed first, like I did at the beginning. And below that, we can use the plier package's command called arrange. Now this command works a lot like sort, except we actually have to tell it which column we want to sort it by, and it works for data frames instead of vectors. You might be able to use it for vectors, but I think you have to use it for data frames. So we can do this again to either alphabetize or put in numeric order an entire data frame. So that's the first thing you need to tell it is what are you ordering or reordering, followed by a command, I think it's by range. If you go, hold on, I'm forgetting my commands now. Range. So, okay, yeah, df is the data frame to reorder, so it doesn't even give you a name, but I know that the next argument, actually it's not df, it's data, which is what I'm calling it. So your data frame here, and then the next argument will be whatever column you want to sort it by, just the name of that column. So it should be sorted by height. Actually, I believe you have to specify that it's within the data column too. So if we do it like that, that should work. Now, if you want to make this so that it's largest to smallest, this would just give you smallest to largest. If you want to make it reverse order, biggest to smallest, you have to tell it by a separate inner command that is DESC, which is short for descending, so descending order. And this should tell it that you want it to sort your data frame in descending order by the height column. So let's see. I forgot to save it as an object, but that reads it out there. So you'll notice that now these tree numbers, which were just 1 through 50, are now out of order. And the tallest trees appear to be Quercus velutina with Acer rubrum and some Caria ovatas in there. And you'll notice that the heights, these are the tallest trees that are in this data frame. So if we want to save this as a new data frame, we could say reordered. And then if we wanted to simply look at that, again, it's the same thing. Or we can look, it's a new data frame, so we can pull it up here, and you'll see that this is reordered. So we could also overwrite that and take out the descending part of it. And then if you look up here now, it's the smallest to largest by height. You can do this with any of the columns that are in here. I don't recommend sorting by presence, true false data, unless you just want only the trues or only the falses. But I believe the next episode I'll talk about how to break up your data into smaller chunks using subsets. So I think that's about where I'm going to call it here. The next couple of lessons, now that you know how to get your Excel data into R, the next couple of lessons will involve how to work with that data. And that will include breaking it down into subsets. We'll look at some statistical tests and also how to plot the data, among other things. So, hope this has been helpful, and thanks for watching.